Welcome to the problem of the week for week 9. This problem requires a lot of algebra and it just was too difficult to try to put it together into a PowerPoint. So I'm going to try and talk you through this algebra, which has been written for you on this page. We're going to start by recognizing we're looking at a problem where we're finding the fourth roots of minus 1, and we have found these roots already in the class. We know that they correspond to z0 is 1 plus I over the square root of 2, that's e to the I pi over 4. And the other three roots are z1 equals iz0, z2 equals minus z0, and z3 equals minus iz0. Those are the four roots of z to the fourth equals minus 1. One thing I want to point out is if I look at z0 and I square it, I will get 1/2 1 plus I squared, which is 1 plus 2I minus 1, which is equal to 2I over 2, or I. And so z0 squared is equal to I. You can sort of recognize that by the fact that z0 is on the unit circle and it's at 45 degrees. If I square it, I have to increase the angle by a factor of 2. That takes me to 90 degrees, but I'm on the unit circle, so that takes me to I. We're going to use that identity that z0 squared is equal to I very heavily in the derivation that we're going to be doing. So the problem we want to compute is we want to find the coefficients a, b, c, and d for this partial fraction expansion, a over z minus z0 plus b over z minus z1 plus c over z minus z2 plus d over z minus z3, that is equal to a cubic polynomial over 1 plus z to the fourth. And so we write the general cubic polynomial as alpha z cubed plus beta z squared plus gamma z plus delta. And so let's expand this out. We are going to expand out that partial fractions. I'm going to first combine the a and c terms and the b and d terms because they end up having simple denominators. We find that they become a plus c times z plus a minus c times z0 divided by z squared minus z0 squared plus b plus d times z plus ib minus d times z0 over z squared plus z0 squared. And now we combine those over the same denominator, and we use the fact that z0 to the fourth is equal to minus 1. We find that we get a plus b plus c plus d times z cubed plus a plus ib minus c minus id times z0 times z squared plus a minus b plus c minus d times z0 squared times z plus a minus ib minus c plus id times z0 cubed, and the whole thing is divided by 1 plus z to the fourth. Please be sure you go through that algebra, make sure that you agree that that is what you get. And now, when we put this together into the equation that we're trying to solve, we actually have a matrix equation. We're looking at the matrix that is 1, 1, 1, because when I multiply that times a, b, c, d, I get a plus b plus c plus d. Well, that's the thing that's supposed to equal alpha. And then I have z0, iz0, minus z0, minus iz0 multiplied by a, b, c, d. That's got to equal beta, which is the coefficient of z squared. And then I have I minus I because z0 squared is equal to I. And that's the thing that when I multiply it by a, b, c, d and add it together, that's got to give me gamma. And then finally, I have iz0, z0 minus iz0 minus z0. I've used the fact that z0 squared is equal to I again. That thing multiplied by a, b, c, d has got to give me delta. Okay, so we now have to form our augmented matrix where we take the alpha, beta, gamma, delta and put that as the last column of our matrix. And now we want to start doing the row reduction. So we're going to take the first row, we're going to multiply it by z0 and subtract it from the second row. And we're going to take the first row, multiply it by I and subtract it from the third row. And we're going to take the first row, we're going to multiply it by iz0 and subtract it from the fourth row. And when I do that, I'm going to get zeros appearing in that first column. And then you get this large mess, which once again, you should carefully go through and verify that you can get the same answer that is written for you here when you do that first row reduction of combining those rows together. Now I'm going to have to do some algebra to simplify this because otherwise the algebra gets so nasty it's really horrible. What is minus 1 plus I times z0? Remember, z0 is 1 plus I divided by square root of 2. So minus 1 plus I times 1 plus I is equal to minus 2 divided by the square root of 2. That equals minus square root of 2. And similarly, I can simplify the rest of that row in the way that you see simplified, and I do the same thing with the fourth row. The third row is already in a fairly simple form, so there's nothing I'm going to do with that. So now I have this matrix, and now it's in a form that I can do the row reduction a bit better. I'm going to take minus I times the second row and subtract it from the first row. I'm sorry, minus square root of 2 times I. I'm going to take the second row and I'm going to add it to the third row. And that's going to give me the fourth row, sorry. That's going to give me 2 more zeros at the bottom. And I'm getting close to having the triangular form. I now have to do some simplification again because I'm going to now formulate this in a way that I'm going to be doing some algebra on it. So I'm going to take these terms that have 1 plus i's in them, and I'm going to rewrite them in terms of z0. And if it's a minus 1 plus I, then that's simply I times z0 and so forth. So we're going to do that massaging and make those changes, and then we're going to also look at the fact that I have to take, let me make sure I get this right, minus I times z0 times the third row, and I have to add that to the fourth row. Using the fact that z0 squared is equal to I, minus I times z0 times that third row, that first element is going to become 2 root 2 I, and is that correct? Minus I, yes. Then that's what I have to add to get a 0 in that bottom triangular piece. So now we've gotten all of that row reduction, and all we have to do at this stage is reverse substitution. But frankly, the algebra to do the reverse substitution is kind of mind-blowing, so I don't want to do it all in one step. Instead, I'm going to recognize that this is a linear problem. So what I'm going to do is I'm going to focus on looking at solving the problem in the case where each of those different coefficients is equal to 1 and all the others are 0. So I'm going to take delta equals 1 and gamma equals beta equals alpha equals 0. I'm going to take gamma equals 1, delta equals beta equals gamma equals 0. I'm going to take beta equals 1, delta equals gamma equals alpha equals 0. And alpha equals 1, delta equals gamma equals beta equals 0. And we're going to then solve for the A, B, C's, and D's in those different cases, and then we're going to take each of those solutions. We're going to take the first one, multiply it by delta, the second one, multiply it by gamma, the third one, multiply it by beta, and the fourth one, multiply it by alpha, add them all together, and that will give us the final solution. So let's look at the first case where I'm setting delta equal to 1. So I have minus 4z0 is equal to 1. Minus 4z0 times d is equal to 1. So d is equal to minus 1 over 4z0. If I look at the next equation, it's 2 root 2 iz0c minus 2 root 2 z0d equals 0, because gamma equals alpha equals beta equals 0. And I can rewrite that as c is equal to minus id. And so I immediately get c is equal to z0 over 4. And then I look at the third equation. That's going to give me minus root 2b minus 2z0c minus root 2I is equal to 0. And I can rearrange that as b is equal to minus 1 plus I times c minus I times d. I plug in the values for c and for d. I find there's a cancellation. It just equals minus I times c. And so I get b is equal to minus I z0 over 4. And then finally, the final equation is a plus b plus c plus d is equal to 0. And knowing the fact that I have b, c, and d, that gives me a is equal to minus b minus c minus d, which is equal to minus z0 over 4. And so I get that result. Remember, this is the result that we actually solved in class earlier when we were looking at expanding in partial fractions for the case of 1 over 1 plus z to the 4th. Now we have 3 other cases that we have to do. They're basically all the same. The algebra is kind of painful. I have kind of written down for you each of the different steps. So in this case, we're going to set gamma equals 1 and all the other terms equal to 0. That's going to affect the fourth and the third rows of the equation. We find when we plug that in, we're going to get d is equal to I over 4. And then we have to do some algebra and simplifying and so forth. And ultimately, we find that c is equal to minus I over 4. And then doing the similar results, we find b is equal to I over 4 and a is equal to minus I over 4. And then there's similar calculations that you have to do for the third case and for the fourth case. I encourage you to pause this video, take a look at the results that are given there with the little hints of that intermediate algebra, and try and go ahead and do it yourself. Make sure that you can keep track with getting all these different results. And the final results that we found for the fourth one were that A equals B equals C equals D equals 1/4. And now we have to put everything together. So I take the fourth solution, multiply it by alpha. I add the third solution multiplied by beta. I add the second multiplied by gamma, and the third multiplied by delta, and I get these complicated results as the solutions for arbitrary alpha, beta, gamma, and delta. And I hope that you can see that this is a pretty complicated thing to go through. It actually took me more than an hour just to write down the equations and carefully work through everything. I'm just summarizing that for you in this video, and I hope that you are able to follow this algebra and be able to go through it yourself as well. It is important for you to sort of exercise your problem-solving muscles and be able to solve problems that are complicated like this, because these are the kinds of problems that you need to solve sort of as intermediate steps in getting the solution of what is often an interesting physics problem that requires you to solve some complicated math problem en route to getting the interesting physics solution. And that's all that I have to say now for this problem on the problem of the week for week 9.